Okay, so let's begin. This was my entry with the alternate reality challenge. So the alternate reality challenge was a challenge made by the Punisher VFX, and as you can see here, there are tons of entries where the main focus was to just create with a character and a focus point of a circle anything you wanted. So I created the following scene. The following scene consists on a bunch of lights with a lot of environment work. I will try to load everything just to take a closer look. And I'm going to shut down the shield. This is the scene basically. It's a guy walking at the middle of the night with, if we can see better at my channel, a exploding or let's say imploding planet in the background. Everything is made up of simulations, everything is made up from procedural workflow. The only thing that's not procedural is the character that drives the cloth simulation. So most of the work is made up from scratch. So it looks like a lot, but everything is made from little things. So let's begin. First of all, I'm going to turn all of this off, otherwise my PC is going to explode, and let's start with the mountain. Okay, so how I started. To start with, I wanted to create a field. You see? I wanted to have something at the background. So I used the height fields. The height fields are some kind of workflow where you can create terrain. And since you can project, you can create a height field and project geometry on top of it, I created some points that were connected, resampled them, and polywire. If we start moving these points around, like this, let's say I move this one here, the height field moves with it. This is a nice technique to create maybe some deserts. If we continue on the height field, I started to blur it out, to add some noise, and to make a mask clear from what I had. And I created some erosion. If I go here and reset the simulation, it's going to start simulating if I let it sim. So what I'm showing right now is something that didn't appear on my show, on my entry, but I have to show it because not always is included. Sometimes you just have to develop ideas and scrap them, like it happened here. What I end up making is from this whole ground I boolean a big piece of land. See, I have this, which is the polywire with tons of erosion, and I have this to be the mainland. I also created a collision for the ground, which creates the collision for the rocks and the smoke simulation. If we go here, I can create a box and I can start projecting on a new piece of land. If we go down below, we can add some noise, we can resample and erode it, and convert the height field to a polygon mesh. Why is this important? Because at least in my workflow, I like working with custom shaders. made up from tree planners. I will go into that later on. I'm going to cancel this and I'm going to show how it looks down below in the proxy. So this is the piece of land I created, if we can see closely with the camera. Let me open the voice chat. Okay. Yeah, this is being recorded, so you can watch it later on my channel. So I have this proxy. This proxy was made out of a high poly version, and what happens is this was around, I believe, 7 to 10 million polygons. I don't have the cache here because I had to delete a lot of things for the entry, since I had like 1 terabyte of files. But this is what I used to render. So I have this proxy, which is going to work later on to scatter some rocks. How did I make, for example, the big rocks? Well, in fact, it is pretty easy. The middle rocks are these ones. I'm going to load them up for a minute. These are the rocks on the middle. See, they are also reduced the farther they are. If I press here, we have this kind of rocks. Everything was made up from a box. It is pretty simple to create. So, how did I do this? I created a box, and inside this point bulb, I do not have anything, so I can turn it off. But then I created a BDB and converted it to polygons. Why? Because I want resolution. I needed resolution to displace it with more quality. So I create a little displacement. This displacement is as easy as creating a noise, any kind of noise, putting a 3D output, and add the current position. This is the position of each point, see? If I say position is equal to position, this is what's going to happen. But if I add a noise to each point to the original position, I can control it. And with the middle class, you can promote a parameter. I already have these parameters promoted, so I can control every single attribute here. See how it's displayed? So this will work as a baseline to create a variety of rocks. I add some normals. It's always good to create some new normals after changing a geometry. And something else I forgot to say is that this rock is anywhere. It's not on the 0 position. So I just changed it with a match size on sensor to the middle. Why? Because I'm going to scatter some points around the surface. I have this, which is not loaded, so I'm going to use the proxy. See? This is already scattered. Let's say I only want to scatter 1 point and only show you how this works. So here what I'm doing is creating a class per connected piece. In this case I only have one, so if I go to primitives, I'm going to have the class 0. But this will work for any quantity of rocks. Let's say I have 2, I'm going to have class 0 and class 1. If I hop into this one, into this for each that circles around the class, it will go through each rock individually. So first of all, what I did here is I created a noise with huge numbers to destroy the rock. See how it's destroyed? Then I did a remesh, which is still destroyed. I really didn't care, because what's funny, or what's really great about Houdini, is that you can always turn that into BDB and resample it back to polygons. See, now it's fixed. I can have some tiny boxes here, which doesn't matter because I can delete them after the fact. So this is only several iterations of the same. So I add noise, I create polygons. I add noise, I create polygons. I add more noise, and I create more polygons. And this is how I create the rocks. The only difference is that at the last iteration of the noise, I use unified noise static with some frequency differences. So if I more frequency on the y-axis, I'm going to have more horizontal lines. If I add a different workflow, a different number, I'm going to have different results. So I'm going to stick back to 1. So always compute the normals after fact and save it. So I saved the rocks on the surface I already have, and this is the end result. See how everything is, it has a really nice resolution. This will come it great later on. So this is the camera at the moment. With almost no effort, we created some really nice rocks. I also have, with the same setup, a rock that goes at the front. If we go to the camera, I believe we can see somewhere. Okay, no, it's transformed, it doesn't matter. So it's really high, but if we deform it and let's wait for a minute, this is going to turn into an incredible rock with more resolution. It's the same as this one, but on a single piece of geometry. So I can transform it anywhere I want. Let's see how this looks. Okay, so this is the result. Only for a foreground element. I could have even added more resolution to the rock, but it doesn't matter. So, how were the tiny rocks created? I have this proxy, and I want to create the rocks where I want them to be. So I painted some attributes here and then there. See? This is useful on proxy geometry. If it was a 7 million geometry, a 7 million polygon geometry, this would take so long. So I created the proxy and I scattered them on top of the proxy. If you have a Quixel, you can do a fast trick inside this node. This node basically is a fast scatter. You can create tons of little things like change the p-scale, the rotation, the motion, the density, anything. But you cannot paint on the surface. So I right-clicked and what I did is allow editing of contents. And I think I broke it down. But basically what I did is I went here and inside of one of these nodes in density, I binded what? What did I create before? I binded the mask. See how it says mask here? So this is a point attribute. So if I go to density and I add here where it says name mask, and then I multiply that by the end result, see how it basically works as a brush? So I can paint anything with this custom modification I make. So if I go here, I can scatter points wherever I want. This is a nice trick. I always have to make this from scratch, but it's a nice fix. So I randomized some things like the variant. The variant works to make integers that iterate from this merge node. So what I'm going to scatter here are just some rocks. See? These are 3 variants of rocks. Some rocks are the number 0, some rocks are the number 1 and the number 2. Each rock is basically the same as the big ones, but on a lower scale. I packed them, so I only have to instance them, and I scatter them on the ground. So these are the tiny rocks, the middle rocks, and the front rocks. These are some simulations which I'm not going to explain these ones because they were not on the final product and they are not seamed, so it's going to take a long. So we're going to hop from mountains to the wind. The wind is something that looks really nice. I'm going to show it. Is the horizontal velocity that goes into my render. This adds some depth and it looks nice basically. Here you can see it from a vertical view. So how did I make this? So I loaded the rocks on the middle and also the rock at the front. I merged them, and if you look closely, let's see on connectivity, we can see that we have 196 different rocks, but I only count 1, 2, 3, 4, 5, 6, 7, maybe 8, 9, and 10. Where are the rest 190 pieces coming from? They are coming from tiny pieces. They are really tiny and we cannot see them, so I'm going to delete them. How? This is a custom node, which is actually pretty easy. It's just a measure. I think I exploded my Houdini. Let's hope it doesn't. Okay, it didn't. Basically, I'm just doing a measure. So then I filter from a certain number. So here will be the tiny rocks, and here will be the big rocks. So I only have a couple. All the tiny rocks were discarded. I also make a poly reduce with a normal. I polyfill if there were some tiny holes here and there. And this is maybe the part that comes in interesting to create advanced collisions. Let's wait until this is reduced. So in order to make advanced collisions, the solution is not just to make a geometry and say, okay, collide with this. No, some geometry has velocity around the collision, around the BDB. And if you mix the collision with the velocity, you are going to have interesting interactions between the smoke and the collision geometry. So how did I make this? Well, if we go closer and let's see our velocities. Okay, they're really big, so I'm going to lower them. Where was this? I always forget. Okay, here, scale vectors, really tiny. So, if we look closer, the velocities are acting a little bit strange because these are the normals. These are the velocities. My bad. Where I always forget where I scale down the vector here. Okay, so I got this. You can see that the velocities on this geometry are like spiraling around the geometry. How did I make this? So if we start here, we can have the cross product. The cross product, if nobody knows, I'm going to use paint. The cross product of a vector basically determines that if you have two directions, let's say up and right, we can have a third vector coming from the perpendicular of these two. Let's say create the cross product of these two vertices. So the result is going to become this. This is really useful when I want to create the cross product from, if we can see closely here, the up vector. The up vector, if we delete everything, is going to be 1, 0, 1. So each point has a normal. Let's say this normal is pointing to this direction, see? And the up vector is pointing up. So the cross product of the up vector and the cross product is going to be pointing at the left side. If I go back, I can create two cross products. One is only going from 0 to 1, and the other is going to positive x. Why this? Because I want to have some swirly noise when I mix them with a noise. If I grab the position and a noise, we are going to change from one vector to another, and it's also changed with time. Well, it doesn't change from time here, but it could easily change from time if we add a promote parameter, and we can see how this move. they start to move a little bit. This is not necessary at the moment, so I am going to continue. When I convert them to BDBs, usually you want to name this as collision. I named it as surface, but it doesn't matter because I fix it later on. And I merged, see how I have the velocity, and I merged the velocity fields. Sometimes when you export from a DOP network, you have the velocity field split into 3 floats, but it is a vector. So good practice is to always add this node, even though it's not doing anything at the moment. So I have this collision with the velocity. The velocity is like the fog. And you also have, let me see, the collision of the ground. It's a polyextrude with BDB. I didn't add any velocity, so I have the collision. So the smoke doesn't go through it. It is the same result. These are both mixed. And I have a sink. A sink field basically deletes the density. If there is smoke coming through here, it gets deleted here. So, see how I have this box? I created some points and I added some velocities coming through the noise. This is pretty easy. Basically, I grabbed some parameters and convert them to a vector, and I add them with the noise of the position. Why? If you go back, here I'm pointing to the negative seat. I know how to say it in English, to be fair. It's basically going that way. And I added with the position and the noise. So if we can look closely, this looks funny. This looks like a swirly noise, which works. This goes straight into the velocity, as we can see here, and it creates some really interesting patterns. If we add some noise to it, you can see how this changes over time. See, it's like a nice pattern. What I did is to offset it on the X position. That's why you are seeing like it moving from left to right. I rasterize this. So this is the source emission, and I created the smoke source. I'm going to press this button in order not to calculate the simulation. I'm going to hop in, and this is my simulation. So I'm not going to explain this part. This is just to create a custom control field, because you can also use anything here. You can create from in the wind, I mean on the gas turbulence, and the control field you could use bell, you could use density, and play with this. I made this workflow. I'm going to explain it briefly. Basically, I create the length of the velocity. So a float of the velocity says the wind is going to the right. Okay, how strong is it going to the right? And I create a mask based on that, and I drive the turbulence with this field. I'm going to lower the smoke object resolution by actually increasing, and I'm going to, I hope it doesn't crash, load a couple of frames. It's actually going pretty fast. So see how this is driving the collision field? As soon as the density touches or gets into the collision, it appears. This is to save resources. So I grabbed the density, which is the source coming from the left, the collision from the rocks, which are these ones, the collision from the ground, which is the ground, and also the sink. The sink is basically a density that subtracts a certain amount of volume. I also created a resize fluid dynamic, so the box shrinks and expands with the density, and that's about it. When this smoke reaches the sink, it will be deleted. If you want to be If you want to be more certain about it being deleted, I think it is loading, you can add instead of subtracting 1, subtracting 10, just to be sure, because sometimes you might end up having more than 10 of density. So if I load this in, with this is the doping port, I basically grabbed the node here and brought, okay, smoke, and I get these fields. The color is not necessary, but I imported it anyways, even though I don't have. And I have this. See how I said before you have the velocity split into 3 floats? Okay, so I merged it. Oh, I didn't merge it. Interesting. In fact, I'm going to show you it. Vector merge. See how it says velocity? If I do this, the velocity gets merged. I think I didn't do it because I actually didn't render it with the actual velocity, so I didn't mind. So I have a saved file here. I think it's not working because it's not actually working because I might have deleted the cache, but I have this one, so it doesn't matter. So I have this, and I time shifted this. I'm not going to time shift this now. Right here, and I can visualize the smoke with the volume visualization. The volume visualization creates. Oh wait, in fact, I didn't delete anything. I'm just not on the right frame. Okay, great. So I have this. I delete the temperature because I don't need it, and I visualize the density. This node is great to pre-visualize on the viewport. Basically, you get the density. You all have to check that you have the density, and you just play with the density field being masked by the density. You can, of course, get more density scale to make it stronger. You can always change this color. Let's say we want white, and you can add more shadows, and if you have lights it looks like this. It looks quite nice, to be honest. I never seen it with lights. So this is how I created the wind. So now we have four more things to say. I'm going to continue with the crystals. So the crystals, these are I wanted to create crystals based on something a friend told me that they were going to look really good. CW, he's here with us. He recommended me to create some new light sources, so I created some crystals. The crystals are similar to the rocks. So how did I make them? I created 2 points where I wanted them to be, and I imported it here. So I have a connectivity going to the points. So I have the point 0 and the point 1. With each point, I scatter and replicated some points. I can change the shape if I wanted to, and I can add some noise and change some attributes, but I just didn't care too much. I also created a wrangle that says, okay, give me the random from the point, from a seed I want, and from the detail of the metadata. The metadata basically is a node that says, okay, we are on the iteration number 1, we are at the iteration number 2, the 3. Anyways, this is to create variation. If this number is less than, let's say, a random number from the class and the seed, some points are getting deleted. So this is how I got a couple of points. I also created a normal, so it points up. Remember, when you have points, they are born without normals. So I created the normals pointing up. I also changed them a little bit. See how they are moving a tiny bit to different locations. And I also created a p-scale attribute that ramps from a random number, so I can have a variation. I created some boxes. This is a box. I grouped this polygon and I transformed it to make it Very little. Thank you, Emil. Okay, so I copy points. If I copy the points, I'm going to have some boxes scatter as I want it to. If I go here, I can change the distribution of the normals, and I can also change the distribution of how many big boxes I have, how small I want. Anyways, I move them a little bit where I wanted them to be, and I say, okay, remember when I had extrude this one, this group, I'm going to extrude all these groups, and I'm going to twist them a little bit. If we go here, we can change this. We can insert it outwards or to the inside, and we can twist them, all of them together. I didn't add a variation because this was not needed, and I turn them into polygons. I convert them right here, and I smooth them out. I also created some little variation. It is the same technique I always use here and there, and I iterate this so they are merged. So I ended up having something like this. I added some connectivity because I want to have one connectivity with this piece, one with this one, and I started creating some cutters. This is a custom node, but what it creates is basically, okay, I'm going to have the ISO offset of this, and I'm going to scatter some points, and I'm going to copy 2 points. I'm going to scatter only 10. I'm going to copy from to these points some grids as shown, which are going to be really big, and I'm going to add the noise, attribute noise, add the normals. See how they changed? So I can do whatever I want with this one. Attribute noise, I can also make an attribute randomize. If I go back here and create an attribute randomize with the normals and set direction or orientation. And if I add a mountain, I can have some noise on these cutters. This is how I created, following several courses and documentation, a custom cutter. It's the same, see? It's basically the same. Why I did this? Because I wanted to split my crystals on different parts. This loading, we cannot see anything, but if we go to the name, we can start seeing the cutters. We can also explode it. See how they are separated on the inside. And now I grabbed from each name. See, I have a name which I named here according to the class. The class is this one, and so I have maybe crystal 1. This is crystal 1, but now crystal 1 divided in crystal 1.0.1.2.3. But I can distinguish between this crystal and this crystal. I turn them each piece into a geometry, and I iterate, and I have this custom geometry. I'm going to turn off the visualizer, and I reduce them a little bit, not necessarily here, and I created a mask on the y-axis. This is going to be helpful for the shading. Basically, it's a relay box, and I grab the y position. I could also use the x position or the z position like this, but I wanted to create it based on the y. I also transform them, and basically they are here. Okay, let's continue. These are the crystals. Okay, so I changed some things and they broke. These are not the originals, but I'm not going to stay with this. Okay, so what I learned in this course is how to make cloth. Cloth is a pain if you don't know how to make them, but you can always learn. So what did I do? I learned. I draw a line. I resample the line to have some points. I edited some of them. I resample them, and I say, okay, let's grab these points. Let's also grab these points and resample them. And I create groups. For example, the inner part of the cloth, this part of the clothes. Basically, I grouped everything. I did a mirror and we fused them. I also made the same for the hood. This is the hood. And if we go down below, we have two pieces of cloth. The back and the front here. I changed the geometry a little bit to prepare it for the simulation. So how did I create this? If we go here, we can add constraints with the balloon constraints and drape it along a collision geometry. So if I load this in, this will freeze at frame 20. But what's going on here? Basically, I grabbed my character, it is this one. I converted it into polygons because sometimes you work in chess with alembics is not right, and I created some groups on the head, on the shoulders, at the hands, the knees, because I'm going to connect that with the cloth later on. I also created some blend shapes because originally this geometry just pops. This would break my simulation. So what I end up doing is to create a blend shape. See how it moves better now? This won't break my geometry. This is basically the geometry with a blend shape based on different positions. A, B, and C. You can watch how it works. And then I start with my original animation. So I have the drape here. This is the T-pose. I also made, based on this, another drape. If we go down here, I added the cloth and the hood. I created some constraint of the cloth, and I end up having a volume drape down below that connects the hood with the main cloak and collides with character. Let's see if this works. Yes, this works just fine. It looks a little bit clunky here, but it could easily be fixed with post-processing. The balloon post-process is created to apply the walls, because otherwise they would be separated because there are two different meshes. At least they were. I delete everything after each balloon drape because it creates artifacts if you create a new simulation, and basically I created new groups. These groups are meant to stick some parts with the collision geometry. If we go down below, there's nothing new. There is oh yeah, there is something new. In fact, I created this new piece of geometry. It's basically a circle with cloth, and I balloon drape it on top of it. You can see it's generating here. It's cooking, and it falls down. See, it's pretty cool. If we go down below, now I have everything I need for the simulation. I started to create the attributes for the final sim, where I'm going to attach these geometries. See, they are working pretty good here. And I started with the simulation. The simulation works just fine. It's a balloon solver, the one from out of the box, and it starts on frame 60. Why on frame 60? Because, well, my blend shapes are there. Let's see if this was okay. This is loading, and this starts moving as soon as the blend shapes moves. So this is like just to prepare the simulation. So it works pretty fine. I have some wind going up here with some keyframes. See how they change. So I have more or less wind with some motion. The motion is basically a way to control a noise on these attributes. And if I go here, I can post-process this. The post-process in this case is based on the subdivide version of the cloth. If I didn't have this, it would turn really blocky. This is smoother. I have some thickness, and that's about it for the cloth simulation. Let's see if I find the cloth. It's here. Yeah, it's here. So I saved only from frame 1 onwards. I'm going to check it like this, and it works flawlessly. So this is only part of the breakdown. I'm not going to go into that. And this is a failed simulation. I originally wanted to have some snow. I ended up removing that. And let's go with something interesting, the planet or the debris. I'm going to start with the planet. So, how did I make the planet? The planet is driven by the geometry Clint gave to us. It's the sphere. The sphere originally moves a tiny bit because it is linked to the camera. See? So I don't want that. I always want to work with freeze geometry. I impact it so I can manipulate the geometry, and I convert it so I can manipulate each individual polygon. I create some normals and I match the size to the center. I always like working like this. Maybe I want to move them with a null, or maybe I want to scatter this. So it's always a good practice to match the size. If I remesh this, I'm going to create a really high density sphere. I should have smoothed this out, but it ended up not resulting in a bad result. Resulting in a bad result, that sounds funny. Okay, so this is a point form. It's a noise. It's the same as the rock. There's nothing different with this. And I compute the normals again. So I have some things to create. I create a cutter which consists, if I go to the wireframe, on tons of spheres. Why? Why did I do this? I created this in order to have some spherical cutters on top of the geometry. I also drive this with a null, saying why it's always nice to work on the center, because then I can just copy the points based on this little fella. I can move it top, bottom, anywhere I want, and it will be really fast. If I go to the Boolean fracture and I click here, we can see, why is this so, oh, because I'm in the wireframe. Okay, we can see some cuts here and there. Always when it comes to fracturing, they triangulate with no polygons. Why? Sometimes when you have n-gons, the shading breaks a lot. So what do I have this? What do I have here? I have the names. If we look closely, we have the name, where it is here. I have different cutters here and there. We can explode this, of course, and we can have different shapes. At the timing, the shape is hollow. That's why I poly extruded it to create some thickness. Remember, it is faster to fracture a surface than a volume. So if I continue here, I add a connectivity and I create the planet name. See how it says planet 0 to planet 20, because I have 0, 1, 2, 3, 4, 5, 6 to 20. I can measure fracture This is the node I showed before to divide the small pieces. See how I have some small pieces that would be really bad for the following process. The following process consists on dividing the lower part, because I'm not going to simulate that, and divide it from everything else. I'm going to add a connectivity on the primitives because I'm going to do a for each primitive, and on each piece I'm going to create some cutters. See how I'm creating some cutters? In this case, the shape is this one, and if I boolean it out, I'm going to have this interesting collision geometry. I'm going to make the same for each piece, so this is going to have more density of pieces on the inner circles than on the outer circles, because the cutters are the same. We can watch better if we create this. See how it's more dense here than on the outer shells? This is a way to control or a way to optimize the simulation. If we go here, we have the bottom part and the upper part. We can assemble this, and this is where I'm not going to press on this one, otherwise it's going to crash my system. But I have the geometry. It is the same but packed, and since I have the sim off, I'm going to double click. You can ignore this. This doesn't do anything. It's so simple. It's just the packed object with a gravity node down below. Since the object is really big, I pumped the gravity to 90 and I extracted the points. After the simulation looked like this, really fast, and it took so long, and I didn't want to do the simulation over and over again. So what did I do? I time warped this with a feed range based on, I made it basically 3.5 times slower. We can see the difference if we do a transform right here and a merge right here. The color of the points represent the name attributes, and the redness means, okay, this is active and this is inactive. If we merge these two and I move them to the left side, we can watch the difference. One is slow down, the other one is at real time. So there's no need to simulate twice if you have the opportunity to create this. I transform the piece. Each piece has a name, as we can see here. This is piece 1, and I have each geometry here with its own name too. So if I transform the pieces, I can translate the direction from the points to the geometry, and it looks really good. It's also fast, and I don't remember if I have the proxy, but I'm going to try. Okay, so we can pre-visualize this with the proxy. This is really fast. It's the same version, but proxy. It's poly reduced, but for render I use the high poly. See? Let's get a little bit closer and see the difference. Okay, so this is great. Now we have the whole simulation. We need to make the smoke. So, where is the smoke? I have tons of notes here. First of all, I want to create some smoke going on the inner parts of the planet, but I also want to have some lines to create a tornado or a vortex velocity field. So I edited the points like this. I resampled this to make it more curved, and I copied to create this shape. I also copied it again with a copy transform to create like a tree, let's say, and I bend it. I bended it like this, so it's swirling. So in this node we can have the tangent at the normal. The tangent is basically a vector goes along this plane. Why is this useful? Because I can create now, if we look closely, I can create some velocities based on the normals. And if we go to volume trail, we can see our velocity working. I didn't change much from here. I just rasterized the velocity field and I plugged it into some of these volumes. So what did I do here? To start with, I created this shape based on the normals. I also created some well, the same thing I created with the rocks. The velocity going along the side. Let's see if we can watch it closer. I'm not seeing anything. I might have the vectors really small. There they are. See? I have some vectors going along the side of the mesh. This is going to be the velocity. I'm also adding some points. This is to create another velocity field that creates a downwards, in this case, a downwards velocity field from the top to the bottom. I save this as a volume, and if I'm not mistaken, I scatter some pieces on the top. I just painted it right here and painted some points. This is where the density is going to be created, and I saved it. Basically, I copy and pasted the wind, and I created a new simulation driven by the source, the velocity, and the collision. The collision is the steel sphere. This one is just frozen here and used as a collision. If we go here, we can have somewhere, at least I deleted it, but I guess I did. Okay, I didn't. So I have this. This is the result of the simulation. A funny trick to create this is, okay, so I actually have the main simulation here. See how it says $FF? This is because I saved 4 substeps. And then I had let's say I have 100 frames. Having 4 substeps will create 400 frames. It will be like decimal numbers. So I have 0.25, 0.5, 0.75, and 1. So 4 frames in a single frame. Then I time shifted this. So each frame divided by 4 and displace it or offset it 100 frames. And I save this again. So I no longer have substeps, but I have a slow version of this. This is always important to create the scale of a smoke. The slower it is, the bigger it is. So I have this one. This is the first one. The second one was created with a torus. I scatter some points after some forming with a mountain. I scatter this and I created a density. This density, oh no, I'm creating some velocities. I then created a pop network. Yeah, the slower it is, the bigger it is, exactly. At least on when it comes to art directing, and somebody says, hey, your smoke simulation is out of scale, it means that either your turbulence is damn small, so it destroys the whole smoke, or the velocity overall is really fast. You can start looking at fire simulations or whatever that is really far from the camera, and if you think something is wrong, it's probably the velocity. So I created this pop network that basically creates this nice motion, and I created some density coming from this. I rasterized the points, which I'm not seeing here. Okay, there it is. Yeah, it's I think the pop network broke. I don't know why. Oh, it didn't work. Broke. It just wasn't simulating anything. So I have this point simulation. I'm going to turn this off, and it creates an nice shape coming from the inner part of the grid. See, it's interesting, and it just works. Then I created some densities. I added some. I set the y position to 0 because it was going everywhere. The burn is equal to the density, and the temperature is equal to the density. Because I didn't want to have a really sophisticated simulation. I just wanted to have some fields to play with. I created some noise on the density. We can watch it right here. This density also moves, and I rasterize everything together. I created by scratch a sparse. Oh no, I didn't create it by scratch. I created this pyrosolver that has everything I need for a simulation on its own, and we can see this, as I said before, just works. What I did here, I went to sourcing, and based on these fields which I have here, burn, density, temperature, and velocity, I created the flame based on the burn. So thanks to Arvid for this trick. And the density is the density, the temperature is the temperature, and the velocity, and the v becomes the velocity. So everything is normal here. This is what I'm going to export. This comes in great for the shading, and I shouldn't have exported the velocity, but anyways. And I created 3 substeps. Why? Because I wanted to have some, I wanted it to look slow. On the solver, the shape, I created some disturbance and some turbulence, and I changed these numbers here. The swirl size 10 because this is really big. So if I created one, on like let's say I have 1, the shape would break because this is like 100 meters by 100 meters. So a swirl size of 10 is great for this situation. What else? The setup. The voxel size I set it to 1 and the start frame to -20. Anyways, I made the same thing and I save a slow version, which looks like this. This is what's going on. If we can see here, is this simulation right here. So since I have finished this, I might need to show you one more, I guess. No, I think I finished showing the smoke simulations. I'm going to double check. I have this one, and this one. Okay, I'm missing this one. Well, oh, this is a nice technique. Okay, you're going to like this. I have the pieces transformed. And from here, I offset the simulation where I want, and I have the what I'm going to render. But I can also use this geometry to drive some sources. So I split the biggest piece, which is the bottom. I have this B-box size, which is saved from the fracture, which is around where it is here. This node saves the size of each piece. So if I have the size of each piece, I can drive anything with it. So I just said, okay, if the size is bigger than this number, get deleted. Well, not deleted, but split it here. See? I also blasted the outside groups. That this comes in with the fracture, the volume fracture. It is only this group. The outside groups are, well, basically what's pointing outwards, and the insides are the cracks. And why is this useful? Well, I can scatter based on the shape size some points. So I am going to promote the minimum B-box size and the maximum B-box size. Why? Because let's say I have a small piece here and I want to scatter 100 points. If I go here, I have a really big piece and I don't want to scatter 100 points here. I need a fixed function somewhere. So I'm going to be driving it with these two floats. This is the main solution. From each piece, I say, okay, scatter based on the reference B-box size. So how big is this one? What's the smallest number I have? What is the biggest number I have? And based on these two, make or scatter this amount of points. In this case, 22. Maybe on the another case, it's going to be 100. So scatter this on every point. See, I have 3,500 points. I mean shapes, which are being scattered. So see, I have tons of points. But what's funny is that I can control everything. So now that I have this is static, it doesn't move. I can delete everything I don't need to save space, width, without and width. I save the points and I point the format with the animation. Why is this useful? Because if I transform this, the actual point number won't change. It changes position but not number. This is important if I want to, after computing the velocity, if I want to create an ID. The ID is based on the point number, and if the point number doesn't change, this won't flicker when I trail them together. In this case, I didn't add them, but if I wanted to add them together, I could just go by groups, say by attribute, and write ID. See, the point didn't change, so nothing gets mixed together. Now, I have the density set to 1, and I have this volume rasterize. This is really easy. I didn't do anything special here, apart from creating or using this velocity. Do you remember, guys? This velocity. Okay, I created a velocity hit with that, and I basically say, okay, simulate and swirl with this motion. This is the simulation, and if we can see closer, we can see, well, it's not so visible here. Let's see with the visualize. Well, there is a tiny turbulence here, like a motion, a circular motion, but we cannot see it, and it's on the final render is basically noticeable, so I didn't mind having this just to create a little bit of smoke on top of the surface of the planet. So I have one more simulation to show you guys, which are the flying rocks. The flying rocks, if my PC handles it, are these ones. Let's go with camera. These are some rocks. They are really easy to make, and they collide with the rocks, with the middle ground, with the ground itself, and they are all driven by Vex. So it might be a little bit scary for some of you guys because I worked with tons of bugs. I hope I didn't crash my Houdini doing this. No, it didn't. Great. So I'm going to leave this as it is, and I'm going to turn this off. Let's go to debris. So this is the whole debris thing. Here is where I created the rocks. It's the same process as the tiny rocks. Nothing really changes here. And I have 3 rocks, A, B, and C. I also have some collisions. You would say, where are my collisions? Here they are. I have the rocks, and well, this needs to load. And I cheated on this one. I created a sphere because I wanted to create, when the rocks impact here, a vertical motion. I also have the round, and I will be creating some places where I can instance the rocks in the simulation. This is driven by a scatter. See, each time it scatters is a new rock generated. Okay, you can go ahead, Arvid, no worries. I'm going to send you the link after I upload it on YouTube. So let's continue. The scatter is based on just 4 points and changing the seed, and I have some nice attributes driven by a Bex function. So this is a multiplication. It's a random multiplication. This is a p-scale. So each point is going to have a different p-scale. This is going to be a scale based on the p-scale. This is going to be the life it currently has, the life it has when it hits something, let's say a rock, and these are not the big rocks. These are, these are the big rocks. These are not the small rocks. So I'm going to I'm going to distinguish between these and these two. These are the small rocks. If you see here, small is turned on. So these are my 2 emitters. They are really nice. They work perfectly. And I have my instance. And what do I have to do now? I have to create the actual simulation. So the simulation is driven by, first of all, a pop source and a pop solver and an output. This is the first part. If you have everything like this, you will be just fine. You will have a simulation driven by particles, but you also want to have an RBD because this is supposed to become an RBD. So you grab here, this is the RBD. You grab wait a minute. Okay, no, you actually just use these 2 instances and then you drive it with this one. Okay, I get it. So you make the geometry. You also grab the collider. In this case, this is a sphere from the force field. And I said, okay, let's simulate this first. Let's go backwards and simulate a tiny bit of motion. See how these are turning white? These are the ones that are colliding with the geometry. They're red for 2 frames because in order to instance some sources, some volume source, you need to stick them into the surface. At least 2 frames. Otherwise, you are not going to generate any smoke whatsoever. With this code, I can create some motion. What I wanted to create is, okay, the first frame have a velocity going to the negative z for a couple of frames, so it's not constant, it slows down here. If you collide and you go backwards, let's create a new force that goes like this. I'm going to use this tool to explain it better. So I have different motions right here. I have the custom pen. I'm going to have the force is going like this. If they go right here, hence slowing down the particle for a couple of frames, I want to have a new velocity that drives them forwards once again. If they bounce but they are below, if they are below 0.5, what I want to make is, okay, no more velocity, stay as you are. So they will just slow down, and stay right at the bottom, colliding with the geometry. This is basically my simulation. When you don't know how to do something, just code it up. I also have some killers. See, when the points are below the ground, they get deleted, and when they are less than negative 25, hence around here, they get deleted. This is to save space on the disk. And I just added some groups. So when it's not falling, hence it's flying at a gravity going downwards. When it's falling, I think these are okay. When it's only falling, remove the swirlness, so there is no swirlness, but it's falling, and drag. Oh, it's always nice to add some drag, otherwise it's going to be really fast. If the here's what I say, if it's below, well, I said 0.5, and in this case it's 0.2, make the drag 1. This is really strong. And finally, if it has an impact, if it impacted with the force field, turn it into white. Once I have all this, I can split this. I can split between everything else and what collided. And I can scatter based on the attribute variant, which is here. Let's see, variant, or ID. I think I use ID. Yeah, I use ID. Well, based on the ID, scatter these 3 pieces. Well, I didn't use ID because ID is really big. I had to use, there is an integer somewhere here. Yeah, variant 0 to 2. So I have the rocks ready, and I grab these points to create, which is, I believe, the most interesting part. I rate them to the geometry and see how they stick really nicely. This is going to work for this part. If we go here, it's going to work for this effect. So wrapping up, basically what I did is creating with the dot product of each point and the normal that gets transferred from this sphere. Oh my god, this is so big. If it collides frontally, what is going to happen is that all the vectors are going to be circular. On the other side, let's imagine this is the side, so the sphere is pointing there. If this was on the side, I'm going to have these vectors, but I'm also having these vectors going to the other side. This is all created with the dot product. So this is how it's working. I also scatter some points. We can watch at the velocities. In this case, it's frontal. In some places, it is not frontal. We need to take a deeper deeper look. Mostly they are frontal, so there's no problem here. And I picked them a little bit to separate from the collision, and I created the smoke interactions. Basically, this is based on the density and temperature, and while the dot network is pretty simple, it's the same as the other ones. There is a collision, there is a velocity, and there is the source. This is the oh, I also have to explain this one, which is actually pretty neat. Okay, this one is based on the sphere, which is subdivided, and based on here, I believe, which is not why it's not working. It should work. Oh, I don't have the geometry. Oh yeah, I do have it. Let's see what's going on. Because I have a solver, that's why. I forgot I used a solver. Okay, what I did is basically, it's not that hard, is I grabbed the points with the color white and the sphere with color black. I assembled them and I added a point to then determine the distance between the center of the point and the outer shell. What I did here is creating, okay, where it impacts, just transfer some attributes, and each time or each frame it goes by, multiply the color by 0.2, hence it goes smaller. Why? Because I want to generate this kind of motion. Okay, this is kind of broken because I guess it's not the last product, but we can see that we have like a noise being multiplied with this kind of motion. This is a Voronoi noise clamped from 0 to 1, otherwise I would have -1, and I made a function out of it. If I connect this to the color, I have everything here. What I did is masking the color which came from the solver, which is in this case white. It looks like gray, but it's actually white. Let's see if I can create, okay, see, white and black, and I multiply them together to create this effect. This is a little bit of motion, and I created a displacement with it. See how it's getting displaced based on the normals. Once I have this, I can save the lambic and I can watch it play live and moving in real time. Once I finish this, I grab or I create, based on this geometry, a volume for the smoke to collide, and I can play, if this doesn't crash, I think I made a mistake here, the simulation. Uh-oh, the spherical of the death. Let's hope this works. Yeah, it's working. Okay, I'm going to cancel this and going back here. This is the same thing. I'm going to lower the resolution with this. And if we play, we can start watching how it works. I hope. The first frame is always slow because it calculates everything. Once it finishes with the first frame, it's going to be faster. Okay, this doesn't work with lower resolutions, but the result would be something like this. Let's see if it loads. I have this simulation. It is awful until I do a volume visualization, and I have everything. Basically, it's the same simulation as the others, but with a wind going on the negative z-axis, z-axis. It's also colliding with the inner part of the geometry, and it's driven by the density, and the density also driven by the temperature. Once I have this, I can create the mesh lights. The mesh lights are created to do the lighting. And if we take a closer look at the camera, and let's turn on the lighting mesh, we can see how they move accordingly. You can create this in Mantra, in Arnold, in any software you want, in every renderer you want. Most of them have it nowadays. So, one last thing I created is based on these smoke files which I created before and driven by a null. I can displace the geometry with it. See how fast it is? And I can also move each individual simulation with ease. Anyways, so this is how my entry got submitted. It didn't enter the top 100, but many people learn a lot from when I recorded myself on the other voice chat from Clint's video. If anyone has a question or anything to add, you can write right now on the voice chat. What do you think? Did you like the presentation?
Yeah, that's cool. Thank you for sharing your workflow.
Great. I am going to be uploading this in my YouTube channel. I hope
How many
recording
render
record.
layers do you
Yeah.
have?
What?
How many render layers do you have?
Oh, I have 5 render layers. I didn't get into the render layers. I have the background. I have the magic, the wind, the foreground, and the shield, basically. And one fun fact, because I didn't got into the look dev, is that each light, how much did I spend? 450 hours, approximately, counting the render times. One fun fact from this is that each light I manipulated the sharpnet to create a light decay, to create a light filter. This is really important to make a good look dev. I also, in contribution, on every node created this, which is basically the name of the light, so I can, let's hope it doesn't crash. Let's hope it doesn't crash if I press this. Okay, it didn't. So if I go to the output and I go to the foreground, take notes on this one. I can add at the bottom the different light groups AOBs. Let's turn a couple of these on. I'm not going to need everyone. And let's hit render. Oh, no problem, Tobias. You can watch it later on, and I'm always here to answer questions. So let's see if this loads. I also rendered this on Full HD and upscaled it using Nuke to 4K. And I worked with ACES. Come on, ask something, voice chat. This is loading. So if we take a closer look, we can see that we have the light groups. And once it loads, because I have tons of geometry, and the first frame takes a little bit. Okay, so I can see the full image. This is the beauty. Let's go to the character. And I can go on every different AOB and see how it looks. Diffuse direct, diffuse indirect, but the fun fact is key are the light groups. Let's see if I have something here. I grab. Okay, so for example, I have this light group. Okay, I create the mesh light based on the crystals and see how I can manipulate only the light that goes from the mesh light, and I'm not getting mixed with other lights. This works really good when you're trying to make the look dev on something. Otherwise, you should have to change the light looking at everything. No, it wasn't Mantra. Mantra is it's a little bit more slow than Arnold, but the workflow is almost the same. So with this covered, I think I'm done. I think I don't have anything more to add to this presentation.
Okay.
Pretty good.
Thank you very much, Pizola.
No, thank you for being here.
I like the idea with the imploding planet.
Oh, yeah.
Looks very.
I was actually going to have a different planet, like a fracture planet, but the idea didn't turn out great, and well, I scrapped it up and created an imploding planet in one day. And I was about to change that idea again, but I said, okay, I don't have any more time. Let's finish with this madness. And yeah, 275 hours to render.